Once again, very good morning to all of you. Dignitaries on the dais, dear participants. I'm very happy to be here. I always feel like my own institute, and several occasions I have visited this institute. And Sir was telling about the several achievements and the way how they are conducting. I have seen the uniqueness in this institute as the involvement of many faculty members. He told he is my own student. So he is my colleague actually. When he was doing PhD, he stayed with my next quarters. We were like very close friends, like family friends. And I have seen many faculty members are here for a long period of time. That is one of the main success of this institute. That's what I have observed. And also, I request each and every one of you to attend such faculty development programs at least once in a year. So go to other institutes and try to see what is happening and interact with the people. So although whether we are technologically, inspiration, at least you can develop the contacts, because that is one of the prime factor, especially in among the teachers, to bring fund and to make a collaboration. Collaboration is one of the major component which is really lacking. We may think that collaboration means one engineer from electrical engineer with a mechanical engineer. Actually, I was a typical Indian researcher before visiting Ireland. After visiting Ireland, my attitude, everything I have changed. I really thank for that University College Dublin, Ireland, for providing a very good funding for me to host almost a period of year. So the complete research culture, even the many things I have learned. So what I request you, collaboration aspect, what I would like to say, when I was in that university for doing postdoc, there was a PhD defense. Excellent work the scholar done on pricing strategy for electrical energy. Pricing strategy, I think at the end of the presentation they have shown the scholar published 2 IEEE transactions. Then they published, they introduced to the scholar after awarding degree. That's a formal introduction of the candidate at the end of the viva was. I really stunned by hearing the introduction about the scholar. She completed BA Economics defending PhD degree in the School of Electrical Engineering. I understood that is a real research. When I asked BA Economics security engineering institute. So that's the way how Indian attitude. Right, even BA Economic Wala is getting a degree from School of Electrical Engineering. That is a real collaboration I have learned. Now, engineers should go beyond our compound to pharmacy institute, law institute, medical institute, even many new institutes. We have to come for the collaboration. Even we can collaborate with a farmer, nothing wrong in that, because we have to do a real collaboration for the betterment of the society. And one important topic is electric vehicle. As I already shared some of the expertise, particularly electric vehicle, most of the mechanical based prime movers are replaced by electric vehicle. And our government really provided a lot of initiatives towards this electric vehicle. I do not know, recently there was a scheme called Maha scheme. I don't know whether many of you have participated in that or not. Government would like to develop 3 centers for electric vehicle, particularly under Maha scheme, and they are going to give the funding support of at least 20 crore for each nodal. We have all submitted, they called for a presentation during February. What I would like to say, hereafter, electric vehicle is one of the main economy driven factor of our country. Employment aspect, semiconductor aspect. Even in 2025, we don't have our own technology for chip manufacturing. Everything is only imported. Even motor we are manufacturing. And the one important component is the chip or semiconductor devices. So the government set up National Semiconductor Mission. They are calling regularly proposal and try to come out with a strong research outcome, not only in terms of publications. And nowadays, even though NIRF is giving importance to publications, apart from that, let us give more importance to patent, technology transfer, then product development, in the sense there are different TRL level. So let us host a TRL level almost 4 or 5. Conceptual patent maybe TRL 1, 2, maximum 3, but we have to move towards TRL level gradually to TRL level 4 or 5. Then definitely industry will come forward to us. As I told when I approached, which is the technology what I have developed in my lab, initial stage during 2017-18 I have received many criticism, but only because of that criticism I have improved a lot in the past few years. Now we are almost developing product level converters in my lab. So that's the way this interaction directly or indirectly will benefit an academician. So I request each and every one of you to have a regular visit to industries, other academic institutes, IITs, NITs, conference to foreign countries. Please have a visit regularly, equip yourself, because we have to go for a long distance of time, right? Long distance over a period of time. So I really express my sincere thanks to the management and the organizing team for giving me the invitation to share some of my knowledge. Thank you, sir. Thank you.
Welcome to the adult-sponsored faculty development program on recent advances in electric and hydrogen fuel cell mobility intended for the PTO research scholars and faculty members working in AICTE-approved institutions from relevant disciplines. The FDP is organized by Electrical and Electronics Department of Jyoti Engineering College. On behalf of organizers, I extend a warm welcome to all our distinguished guests, esteemed speakers, and participants. Let's move on to the session 1, Hybrid Storage System in Hybrid Electric Vehicles. I invite Dr. Kumaravel S., Associate Professor and IT Calicut for the session.
Thank you, madam. So very good morning to all of you once again. So based on my request, they have agreed to start the session because I have to leave by 12 o'clock. I have a train at 1 o'clock. And today, unfortunately, I have applied half-day leave. And I have a CPRA project evaluation at 3:45. I have ensured my scholar that I will reach around 3 o'clock at NET campus. So thank you for your cooperation. So, in fact, I am here to deliver a lecture on hybrid storage system in hybrid electric vehicles. Especially for the past 5 years, there are plenty of workshops, seminar, conferences going on in electric vehicle. In fact, in AT Calicut, 2 years back, we have started an MTech program in electric vehicle. Such an important topic, it turned all of a sudden in the past 5 years. There are many institutes, they are also starting a MTech program in electric vehicle certified courses. There are many opportunities for electric vehicle. In fact, I appreciate the organizing team of Jyoti Engineering College to host this event in the right point of time. So when you go to electric vehicle, in fact, there are different vehicle, particularly this hybrid electric vehicle. So which is one of the major thrust area, and definitely comparing to a pure electric vehicle, a hybrid electric vehicle is having plenty of research opportunities. At the same time, product development. There are many indigenous technology with the help of an academicians and the collaborations with industries are coming up in the past 3-4 years. In fact, in NIT Calicut, we have joint collaboration with the Tata LXI as well as Robert Bosch for developing some indigenous technology at NIT campus, and there are some sponsored research labs we have started last year. So, particularly storage, which is a mandatory in the case of an electric vehicle. When you talk about battery storage or fuel cell, although fuel cell is a generator, we are often calling it as a storage. So when you talk about storage, not a single storage, it's a hybrid storage. So hybrid means more than one storage element, right? So we are integrating more than one source as a hybrid storage for hybrid electric vehicle. Hybrid electric vehicle has both IC engine and electric drive. So I think you may have some clear picture about a hybrid vehicle. So before proceeding the session further, so let me just ask a few things about your expertise. What is your expertise, madam? Which area you are working? Please sit down, madam. Sit down. Power electronics. Anything related to electric vehicle? No. Which part of power electronics you are working? DC-DC, DC-AC, AC-DC, control strategies. Control strategy you are working. Power electronics, particularly application of power converters in power systems. Is it like that? Good.
Sir, I majored at power systems engineering.
Power
But
system.
right now I am working in a EC department, sir. But I used to know.
Oh, EC department you are working? Ah, okay. They are immigrating from computer electrical engineering to computer science. Or computer say for ECE
No,
because
sir.
admission is less. There's no way because we have to survive. Even if you want to do, even if you ask me to teach arts also, I am ready to teach. What shall we do? Because fitness of survival is a matter. Okay, please.
So mechanical.
You are from mechanical background. Okay. In which anything related to electric vehicle? No. So where you are from which institute actually?
Colleges Academy of Engineering.
Okay. Pala.
Mala.
How do you say?
Suresh.
Trishura. Okay. Yeah, he is well known to me. Please sit down. Which area you are working?
Solar.
Solar PV integration, power converters. Okay.
I'm also on power electronics and working on with wireless power.
Oh, wireless power transfer. Very interesting topic. Yes.
I'm from electronics.
We take half wave symmetry. The waveform. If it is a square wave or a triangular wave or a trapezoidal wave, the waveform is half wave symmetry. Now half wave symmetry angle no even orders will be there. All the even order harmonics will be 0. Play. Odd order alone will be there. Fundamental is 1, 3rd, 5, 7. Again, series. So usually we classify the harmonics into two categories according to the order of the harmonics. One is a lower order harmonics and the higher order harmonics. Usually the harmonic order lesser than 11 is called as lower order harmonics. Above 11 is called higher order harmonics. Usually this classification is based on the impact what it is producing. So if you write a coding in MATLAB, you take a fundamental voltage.
Sir, is it based on 50 Hz, that level?
No, sir. Anything you can take, 50 Hz or 60 Hz system. That's what I am trying to convey the answer for that question. In MATLAB exercise, tutorial session no. Tutorial session this question if you go to simulation practice you can insist them to do this practice. You take V is equal to Vm sin omega t. A fundamental. If you write MATLAB coding, you know how to visualize the sine wave. Generate a third order harmonics. You know what is our third order harmonics? Vm by 3 sin 3 omega t. Vm by 3 sin 3 omega t. Just in MATLAB, add these two. Vm by 3 sin 3 omega t plus Vm sin omega t. If you add these two, you will get 3 peaks totally. You know what is a sine wave? I think is it possible to write here? If possible to write, I will write here. If you provide a pen, it will be convenient for me. You can just bring it, no problem. Okay. No problem. I'm doing that. Thank you. Yeah. What I am conveying. So this is. I think it is visible now.
Yeah.
It is visible, right? This is the fundamental voltage Vm sin omega t. I am going to add 3 omega t where the frequency is 3 times the fundamental. Let me take waveform like this. Like this you can. I don't know, madam. Yeah, no problem. Just you break it. I will. So if you add these two waveform, how it looks like? So positive and this.
Positive.
It will need a wave shape. What I have drawn here is not that much visible. It will need a wave shape. What I have shown there. So, if you see here, it is having this two upper peak and lower peak like this. This is the effect of third order harmonics. If you add a fifth order, which is Vm by 5 sine 5 omega t, you will get two more peaks. Like that, if you add all the lower order harmonics, if you add all the lower order harmonics one by one, you will see when you add the 11th order harmonics, the wave shape almost like this. You can do this experiment, madam. You can do simulation exercise. Just to draw Vm sin omega t, add the waveforms like Vm by 3 sin 3 omega t, Vm by 5 sin 5 omega t, 7 omega t, 9 omega t, 11 omega t. Stop. Then you will understand the severity of change in shape almost a square wave. So that's why we are calling it as a lower order harmonics. The effect of lower order harmonics on the system is very, very high. At the same time, you do another exercise. Take sin omega t, add the 13th order. Vm by 13 sin 13 omega t. We are classifying into lower order harmonics and higher order harmonics. And what I am conveying now is the effect of these harmonics on the induction motor. That's the way how we have started, right? So I told Vm by 3, Vm sin omega t minus 120 minus 240 will make the revolving field that we already studied. We come to third order. If you come to third order, what happened to third order? So 3 omega t, right? So what happened to the R phase, Y phase? So it is something like Vm by 3 sin 3 omega t minus 120 into 3. Now what happens? 3 times 120 is 360. So sin A minus B formula, if you write, this sin A cos B minus cos A sin B. So if you write sin 3 omega t into cos of 120 into 360 minus cos 3 omega t into sin of 360. You know what is the value of sin 360 is 0. So this portion will be 0. So you have sin 3 omega t cos 360. You know cos 360 is 1. So it will be sin 3 omega t only. So R phase I told sin 3 omega t, but Y phase supposed to be minus 120. But multiply by 3, it becomes 360. So it is equal to sin 3 omega t. If we do for B phase, it is minus 240, right? Minus 240 into 3 is 720. 720 is 2 times 360. The effect remains same. What happened? You will get 3 sine wave where each waveform is Vm by 3, right? The frequency remains same. In phase component will get. So you will have the cumulative as Vm sin omega, Vm sin 3 omega. Yes, we are going to add 3 waveforms, right? So Vm by 3 sin 3 omega t. If you add 3, it will become Bm sin 3 omega t. What happened to those waveforms? It will turn as a triplen harmonics. This is called triplen harmonics. Usually when you see a 3-phase waveform, it will be 120 degree apart, right? It will be like this. Like this. What is the phasor sum? What is the phasor sum of a 3-phase? Always 0, right? Or you can take instantaneously. You take a particular instant, again 0. But in triplen harmonics, it will be never 0. So it will turn as a neutral component. If it is a star connected system. Usually in induction motor, we go for delta connected winding. You know very well, right? Say sometime you might remember about the star delta starter. Starting in star connected and running in delta connection. If you have a star connected system, this triplen harmonics will go like a neutral component. Unfortunately, in delta connected induction motor, that only we prefer. Delta connected induction motor only we prefer. There is no neutral. Then what will happen to this triplen harmonics? This triplen harmonics will turn as a 0 sequence component. You know, positive sequence, negative sequence, 0 sequence. This 0 sequence component will revolve in the winding itself. Suppose you have a delta connected winding. It will revolve in this itself because there is no neutral. Now what will happen to the effect of that voltage will cause a current. Then what happened to I squared R loss? Then what will happen naturally? Heat will increase. That's the way how triplen harmonics degrades the system performance. Now you understood, no? People usually will say, sir, harmonics will produce more heat, more heat. How it is producing more heat is a question mark. Now you understood how it is producing a heat. Because there is no neutral, so it supplied among the winding. So if you draw the equivalent circuit of, you know what is equivalent circuit of induction motor? Same induction motor you can draw in the third order, right? So if you do it, and it is not a per phase equivalent, you will get one equivalent. Why? R phase, Y phase, B phase remain same. But if you draw the equivalent circuit of an induction motor, it is valid for per phase. You get my point now? Now, this will never do any mechanical torque. This will never produce any mechanical torque. What it is doing? It is only heating the system. It will never produce any mechanical energy. But there is a current flow through the winding, no? So that energy is dissipated only in terms of heat, nothing. You get my point? That is the problem of third order harmonics. That is called triplen harmonics, like 3, 9, 15. These are the significant problem of this triplen harmonics, right? Now I am coming to fifth order harmonics. If the order is 5, sin 5 omega t. Now 120 into 5 is how much? 600. 600 can be written as 600 minus 720 is how much? Now
and for this invitation. So as you can see from the topic, we are going to discuss about the various technologies related to electric vehicle. So I am, as it was introduced, my research area is basically power electronics in drives, where the direct application falls widely in the area of electric vehicles. So as a part of our research, in our research group, we are working together to solve various technological issues related to electric vehicle. The main being one side of it is the charging part. Other side of it is the drive. So both areas are equally important, and we have different ways of working together to improve the technology related to both drives and battery technologies. Not battery technology, basically the charging part. Okay? So we will just widely see those technologies related to electric vehicle, their challenges, and what are the few solutions what we had proposed in those areas. I think you might have been already familiar with these things, but to just give an introduction, electric vehicle is not a new technology, right? It's a very, very old technology. First vehicle which was made, it was electric vehicle, right? But why it did not advance? Why did petroleum-based or IC engine-based vehicle gained a lot of importance? Storage was a big problem, because at that time there was only the basic chemical-based storage was available, which was very bulky, right? A storage of say maybe a 20 ampere hour or so will be of a size of this room. So that storage has to be carried by the vehicle. So that was a big challenge. To have a compact storage was a big challenge. Another thing was there was scarcity of the motor technologies. Okay, we had only DC motors. AC was not even found. I am talking about the 18th century, where there was not even a discussion of alternating current. Only direct current was there, direct current motors, which were very bulky. So the motor itself was very bulky. Then there was an attractive solution which came up later, right? Which was by the petroleum-based engines, what you call as internal combustion engines and all. Even though they have very low efficiency. Why they have low efficiency? The basic moving part what we get from an internal combustion engine is a linear movement, right? It has to be translated to a rotational moment through a lot of mechanical elements. So whenever you connect a mechanical element, there is a lot of friction, wear and tear, right? So the efficiency of any mechanical connecting element cannot be more than 70 to 75%. And they are coming in cascade to the output. So the total efficiency is coming very less. But even with that efficiency, IC engine gained a lot of importance at that time, because when compared to the other technology, this was far more advanced, right? Far more easy for the people to take it up, far more adaptable, right? But then what happened after 1970s? People started to talk again about electric vehicle, right? One, there was a huge botheration about the environment, green technology, all those things were coming up. Also the fear of having lesser amount of petroleum available later on, or the cost of petroleum was also giving some importance to the electric vehicle at that time, right? But beyond that, the main factor which led to this confidence of going back to the old technology of electric vehicle was the invention of thyristor. In 1970s, thyristor was invented, right? And after that, the power conditioning became easier. Means, whatever be the form of power available to us, we had a confidence to change it to any form which we require. Till now, wideband gap-based WBG switches are all available. So there's a lot of development in the switches, semiconductor devices, microprocessors. When we say that we have to give a switching pulse, that the thing which does the control of it, the brain of it, is a microcontroller, right? There is a lot of development. Even the most fastest microcontrollers are not very costly nowadays, right? So that also gain a lot of confidence. Again, third part is the motor. Instead of having only one DC motor, with that fixed characteristics. Now we have a wide range of choice of motors available, right? So if you look at it, we have from AC machines, we have induction motors, right? Then there are a lot of special machines, permanent magnet synchronous motor, what we call as PMSM. Then BLDC, brushless DC motors. They're all permanent magnet based, right? Then there are other DC machines are there. Then there are permanent magnet free machines, which are going to be, actually they are going to replace all these permanent magnet machines in the coming future, because we don't want to have a dependence on the permanent magnet as well. Okay? So they are called as reluctance machines. Synchronous reluctance machines are there. Switched reluctance machines are there. So many choices of motors are available, right? Now with that, we have a wide choice of torque speed characteristics. So then we just have to feed the required voltage at required frequency to get the required torque speed character. That's all. And that part was made available because of the switches which are there. Okay? And also the amount of energy it carries will determine the range of the vehicle. So the energy density must be very high. So that also was required, which is the electrochemical component of the whole setup, where nowadays there are various choices for that as well. Various types of batteries are there, and the choice of the battery and the motor will be dependent on what are the criteria we are looking at. Right? Suppose I am looking at a very cost-effective solution, but not much bothered about the performance. I'm looking for a very short distance, small application vehicle, where I want the vehicle to be very cost-effective. Least cost is the only consideration. Then my choice will be maybe a lead-acid battery among the batteries, and maybe in the motors I may prefer either an induction motor or a DC machine. Right? Less cost. That is the only thing I'm bothered about. Suppose then I am looking at certain other things, like I don't mind whatever be the cost, but my priority is the performance. Right? The performance will be the performance of the battery. I want the battery to be capable of handling a wide range of temperature. Then the choice will be different. Right? So in between there is an optimum choice, like which will fulfill most of the criteria, and that is a lithium based battery. So that is why most of the vehicles which you are seeing now will be using a lithium based battery. Okay? But lead acid is there for a small application vehicles. If you see the buggy vehicle and all, they use lead acid batteries. So any battery can be associated with any motor, only that we need to match the voltage ratings. Okay? So there is nothing like I have to use lead acid with only one type of motor, nothing like that. Batteries will just act like a voltage source. Only that the voltage rating of the motor has to be, if we are using say an induction motor of around 400 volt, 3-phase induction motor is the one we are trying to use, then the battery which we will be using will have to be capable of providing this 400 volt AC, right? So if you are using a 3-phase inverter stack, then the battery side, the DC side voltage must be at least 700 volts. Okay, so either we can have a battery which is 700 volt rating, very difficult. Why is it difficult to increase the voltage rating of battery? Yes, batteries are what? A combination of cells. So cell voltage is limited, say 3 to 4 volt. So if you have to increase the voltage rating of battery, the number of series connection of cells increases. What is the problem? If we have more number of series connection? Size, okay. Resistance, yeah. Main issue with the series connection, why do we connect all the loads in parallel, not in series?
Voltage rating should be
Voltage rating must be same. Voltage drop must be same. Okay, that is called as a voltage balancing. Yes, there is a chance of an imbalance of voltages. What will happen when there is, suppose you have two cells in series. Okay, each are 2.5 volt rated. Okay, so to utilize it maximum, we have applying a 5 volt at the terminal. Right? Suppose one cell is weak. It takes only 2.4 volt. Not a problem. What will happen to the other cell? Goes to 2.6. That is a problem. Because 2.5 is a rating. It will damage that cell. Okay? So imbalance in voltage may cause an overvoltage in some of the cells, causing its aging faster. So we want the voltage to be balanced. What is the way, one way in which it can be done is, we can assume that even though the rating is 2.5, some cells may become 2.4. So let us fix the voltage to 4.8, not 5. One way, right? But what we are doing indirectly, underutilizing the cells. Right? So we are one way we are talking about energy density, etc. But then underutilizing is not falling in that line, right? We want to utilize it more at the highest way. Only then we have good energy density. So balancing is a big issue. So there are a lot of balancing circuits which have come up. Okay, we have also worked on few. We'll just touch upon them also. So that is one issue. Next is reliability. When you are connecting things in series, one goes bad, the whole string performance is bad, right? So any series connection is less reliable than parallel connection. So that is again one other reason why the voltage is not very big. So to get a 700 voltage across to supply a 400 volt induction motor, what is usually done is a battery of around 300 volt is taken and a boost converter is kept, which will boost that to 300 to 750 before applying it to the inverter. That is a structure in which most of the units are working. Okay? So that is the only consideration we need to see. Or what is nowadays, what is another thing which is being discussed is motors being our mobile battery or our mobile phone. Can we charge it from, we have now various choices for chargers. You have seen many chargers which are marked as fast chargers, right? If you clearly see the spec of it, it will be delivering 8 to 10 amperes, wherein the normal chargers are giving only 2 amperes, right? So a mobile which is coming with a charger or a battery which is suitable for 2 ampere current, what will happen if you are using a 10 ampere charger to it? It will damage. Why will it get damaged?
the sedimentation of its.
Sedimentation, yes. What causes that? There is what is happening when you are charging a battery? There is a chemical reaction, right? Oxidation, reduction reaction is happening. Every reaction takes its own time to complete, right? A minimum time is required for those reactions based on the materials being used. So to that optimum value is what is given as the current rating for every battery. Okay. Now if you are giving a current which is beyond that rating, what you are doing? You are trying to increase the rate of these reactions, right? When you are increasing the rate of these reactions, many of those reactions will become incomplete, right? There will be more of settling, some other residues will be found which are not good for the battery, right? Then we say that the battery battery has become aged, right? So even though we have the infrastructure to provide a larger current, but all the batteries may not be capable of taking it, right? And we need fast charging. Why? Even for a mobile, if you are having half an hour to charge a 5000 milliampere hour battery, which is running a mobile, okay, imagine a car. What will be the ampere hour rating? How will we calculate? Suppose you take a car which has a motor which is 10 kilowatt. Okay, a 10 kilowatt motor. Okay, and I want that motor after my battery is fully charged. I want the motor to run for 5 hours. Right? 10 kilowatt motor for 5 hours. So what is the energy required to do that? 10 kilowatt hour. Minimum 50 kilowatt hour. Right? 50 kilowatt hours is minimum energy. Efficiency and all we have assumed it to be 100%. Otherwise, be more than that. Now kilowatt hour means it is ampere, volt ampere hour. Right? Divided by the voltage rating of the battery will give you the ampere hour. Right? So 50 kilowatt hour divided by, let us assume it's a 250 volt battery for easiness. So 200 ampere hour for a 10 kilowatt motor. Okay? You have seen this Nexon, new EV Nexon. What is, have you seen the specifications anywhere? What is the power of the motor being used in Nexon? 100 kilowatt hour. Okay? 100 kilowatt hour motor is used in, so 4-wheelers nowadays. It is not that we use 100 kilowatt always. It is for giving all those extra profiles for it. A good acceleration, etc. That power is increased. But still, the motor comes around 100 kilowatt for 4-wheelers. Okay? 5 to 7 kilowatt motor for 2-wheelers for giving good performance. Okay? So in such cases, you imagine what is the rating of the battery, 200 ampere hour, which is around 40 times more than that of a mobile battery. Right? 5 ampere hour. Right? So what will happen now? You are going to charge it. What does it mean? 200 ampere hour means if you are supplying 200 amperes, it will get charged in 1 hour. Right? 400 amperes, half an hour. 800 amperes, 15 minutes. So it is now very difficult to make a fast charging. Right? The infrastructure is difficult. Right? Second, even we increase the current, the battery may get damaged. You have seen these charging where there is a direct connection to the battery terminal where the charger part, the power requirement, the power electronic circuits which makes a charger is not inside the vehicle, it is outside. So we can make it as big, whatever be the power rating, it doesn't bother us because that is not carried by the vehicle. So it will be something like a charging station made like our petrol pump where the charger itself is outside. Okay, so that is charging or fast charging where the output of it directly goes to the battery terminal, not through this part. Okay, now this is the charging port which will be used for charging in most of our charging stations which are available. Okay, they are connected directly to the battery terminals where a current of very high value suitable for that battery is given. Okay. So if you see the existing EVs, few of them, and the onboard chargers, what you are seeing here, you can see that the onboard chargers are always very low rated. Just to take the Tesla Model S, it's a 100 kilowatt hour battery with the 400 volt rating, is the voltage rating of the battery. And the onboard charger is 17.3 kilowatt power. That is the largest among this. Okay. But then, what is the charging time? 100 divided by 17.3. Almost 5 to 6 hours it takes to charge. Okay. If you take all the examples, it is like that. So onboard charging means 5 to 6 hours. Otherwise, it has to be charged through the DC charging port, where again it will be not less than 30 minutes. Okay. Now this is the two supply. EVSC is what it is called as, the charging stations what we see everywhere. It is called as electric vehicle supply equipment, and there are a lot of standards which prescribes what is the kind of plug to be used for onboard charging and fast charging. So these are the plugs which are now available as a standard in India. Why are the standards made, first of all? Yes. So if a vehicle manufactured in Kerala may be charged from Jammu Kashmir. So there should not be a compatibility issue. So there will be standards for every nation. There will be some standards which are also international, right? When the vehicle is also made with those standards. In 2020, there were no much standards for electric vehicles in India. After 2020, the standards have come up, and still they are getting added up, meaning more things. As there is more application, more people using it, there will be more requirements, more additions to the standards. Okay. Fine. So another main issue with the battery, as I said, is the aging of the battery. Where why we are bothered about the aging is, one, we are trying to do a fast charging. So we are going to increase the current. Okay. At the same time, if you buy a vehicle, more than at least 50% of its cost is that of a battery. Okay, so after 5 to 6 years or before the tenure where the battery is ending, if you are planning to replace a battery, it is very costly. Okay, so the aging of battery is a big concern, especially when we think about fast charging. So we need to find a solution for this issue. One is there has to be some development from the material side, from the chemical engineering side, where the battery technology becomes capable of doing this. Another is we can think about some other alternate way of storage, which is also capable of taking it up. Okay, so what we have worked upon is another type of a storage. We'll discuss that. Before that, another issue when we say about fast charging is its impact on our grid. Okay, so what is the impact it can cause? Demand is increasing, yes, that is one big thing. Demand which is unpredictable from various points. Another issue is batteries are all DC loads, right? And the supply what we have is an AC supply. So there is always a requirement of a rectification, right? Whenever there is a rectification, there is a power quality issue associated with that. Have you heard of a very big example of power quality where there was an experiment with the CFL lamps? We have heard CFL lamps were now replacing, in maybe in 10 to 20 years before, it started replacing incandescent bulbs. CFL lamps requires a rectification. Okay, so there was an experiment conducted with not very good quality CFL lamps where this extension board was there, where there were 5 CFL lamps connected, maybe each of 10 watt rating. Okay, so 50 watt. And the extension board has a fuse wire, maybe 2 ampere rating. Okay, the moment the switch was turned on, the fuse blew off. But the power, when we calculate, it's not more than 50 watts, right? Why does that happen? The current is not sinusoidal. How is the current? It's a peaky current. If you can just see, simulate a rectifier with a capacitive load, capacitor and a resistive load to the supply. The current will be having a peak to the middle of that sine curve, right? Now that peak current has to supply the RMS value required for the load, right? So the peak value of that current will be 10 to 20 times more than that of a sine, right? Imagine 5 such currents coming at the same instant. Instantly, that peak will be much larger than 2 amperes, blowing it off. So what is the problem it has caused? Because of the shape of the current getting deviated from sine.
Sine.
That is a power quality issue. What caused that issue? Rectification with a filter, capacitive filter, right? Now we are going to have so many such things, and now we are talking about 800 ampere, 1000 ampere, etc. Right? So what will happen then? To such, to the utility grid, we are going to cause a lot of trouble if we don't purely manage the current. Right? If those currents are not made sinusoidal, it is going to be very harmful to the grid. Those who are working on renewable sectors, you might have studied, and maybe around